Let's go back and look at one of the pipelines that we have seen before. There is always a big confusion when it comes to which thread is exactly triggering the different stages of the pipeline. In this lecture, we will spend some time clarifying this point. Look at the pipeline on the screen. Let's say that this pipeline is created by thread X. Just giving a name to the pipeline creation thread. Now, which thread executes the task supplied to supply async? We know this. It's one of the threads from the common fork join pool. That's the default. Let's call this common.thread0. Now, which thread calls the function supplied to then apply? Now, the answer to this question is it depends. Here's the rule, and it's critical to understanding who triggers the next stage. If the next stage in the pipeline is available, then the thread that completes the current stage will immediately trigger the next stage. In most cases, the task will take a while to execute, and so the function supplied to the then apply would get called on common.thread0. And so also the consumer passed to then accept. Note that the then apply method itself will be called by thread X, but the function passed to then apply will be called by common.thread0. The former is part of the pipeline creation process, and the latter is part of the pipeline execution process. I had talked about this difference in a previous lecture. Now the problem becomes confusing when the thread creation process and the thread execution process run in parallel, and this can happen sometimes. So under what circumstances would the next stage in the pipeline not be available? Let's take an example. Let's say we break the previous pipeline into two, as shown on the screen. I have put a sleep of 5 seconds in the middle to mimic some synchronous call. Such a scenario could easily happen because the pipeline need not be created as a single statement. A lot of times, the pipeline creation can span several methods, each method adding its own stages. In such cases, there might be statements in the middle which eat away precious CPU time. That's what the timing of 5 seconds in the middle represents. So let's try again. The pipeline creation thread is thread X. What thread executes the supply async task? Common.thread0. What thread now executes the function passed to then apply? Assuming that the thread executing the do task has already ended within 5 seconds, common.thread0 may now be doing something else. So the then apply stage is triggered on the same thread as the thread which calls the then apply method, and that is thread X. Now this makes sense because at that point when thread X calls the then apply method, the previous stage has already completed, and the result is already available to be used for the then apply stage to be triggered. The then accept stage is also triggered by thread X. Now this comes as a surprise and also is a bit of a problem because if one stage in the chain is triggered by thread X, then all the rest of the stages after that might end up getting triggered on the same thread. This is a problem because we don't know how much time a stage which is going to come later is going to take. And we started with the notion that we don't want to block thread X. Fortunately, Completable Future gives us some async methods where it is guaranteed that the various stages will be triggered on a different thread. Let's take a look at this pipeline. Here you see that the methods used are then apply async and then accept async. When we use these methods, the function and the consumer that are passed to them will be triggered on a new thread in the common pool. Here are the thread labels for this scenario. You can see that both the function and the consumer are called by different threads in the common fork join pool. And this is true even if the pipeline is split into two and you put a wait in the middle. Now there is yet another version of the then apply async and then accept async, which takes in an executor service. When that is used, the stage will be triggered on a thread from the executor service and not from the common pool. As you see in the example, we are passing my pool to the calls of both then apply async and then accept async, which is a different executor service. So both the stages will be triggered on that pool, my pool, and not the common pool. Here are the thread labels for this scenario. You can see mypool.thread0 and mypool.thread1 executing the then apply stage and then accept stage. The final word here is that other methods in the completable future class, like then compose, then combine, also have an async version of the methods, and they can also be used. So hopefully this clarifies the confusion about which threads trigger the various stages. Also, we should use the async version of the methods so that the pipeline creation thread does not get blocked.